Hello, guys. Good day. Welcome to this wonderful section which talks about the introduction to functions. Here we are going to get to know the understanding of functions, the definition, representations, and the texting of it, which we are going to use the vertical line text to text for functions. Okay. Let us get to know what a function is. So here, what is a function? A function f from a set A to a set B is a rule that assigns each element in A to exactly one element in B. It means that we are talking about a relation between two sets, which is the set A and set B, where you see each of the elements in A having exactly one element in B. So we can also put it in this way that every input has exactly one output. So if you see a relation where an input results in exactly one output, then it means that we can grade it or term such a relation as a function. There is also something that we need to understand. Not all relations are functions, but all functions are relations because we have types of relations: one to one, many to one to many, and many to many, which signifies that not all relations are functions, but all functions are relations because a function is a relation between two sets, which is A and B, where it is in the form of a rule which assign each element in A to exactly one element in B. How do we represent function? A function can be represented as f bracket x, which we read as f of x. The input is the x, that is the one that we input, that is the object, and it is independent variable. Then the output is the f of x. It is the one that depends on x, and we call the output as the image. So the input is the object and the output becomes the image. How do we represent functions? We already have the idea from the first slide. When it comes to the second slide, we can represent functions in ordered pairs, like the ones that you see here. The x input, that is -4, then the output is 16. Input, that is -3, and the output is 9. Object is -2, and the image here is 4, and so on. A function can also be represented in a formula form, like the way it is right now, which indicate the rule. So here, the ordered pairs of functions, which is now being listed here, now can be written in a rule form. So the rule form is saying that if I want to find the output, then the input square will give me the output. So here the input is -4. So when you put the -4 here, then we end up getting the output to be 16 and so on. And it can be represented in a notation form saying that f is said that x map to, that means each input is relating to the rule of x power 2. That is it. Then we can also represent the function in the graphical representation format on coordinate plane. Let's see a real life example of a function. We can take our end of semester grade calculations. J represent the 30%, that's the class score, and plus 70% for the exam score. That would be able to grade it. That is when we can get a perfect grade. J is a function of classwork C and exam score E. So each set of class and exam score gives one final grade. So that is an application of a function combining both class score and exam score to produce a final grade. Let's see, work on this particular activity, graphical activity. That is, we are going to plot a certain unique function, and the name of that function is quadratic. And these are the ordered pairs here. -4 to 16, that is the input. Then here, this one becomes the output. So connect the point to form a curve like what you see here. So all this side, you can see the graph at the other section, where when you look at 0, 0, when you come to the graph, you can find 0, 0 exactly at the origin. Then you see the -4, 16, -3, 9, -2, 4, -1, 1, 0, 5, 0.5 to 0.25, and so on. So when you join this curve together, you're going to realize these points together, you're going to realize it's going to create a curve, and that is called a quadratic curve, and it is in the form of parabola. Okay, so you should see a parabola, which is the graph of a function y equal to x squared. And how do we test if a relation is a function? So we can use something we call vertical line test. To test if a graph is a function, draw a vertical line through the graph. If a vertical line intersects the graph at more than one point, it is not a function. If it intersects only once at every location, then it is said to be a function, as shown in the next slide. You can see diagrams and graph in the next slide. So examples using the vertical line test. We have a parabola here, like the one that we sketch on the graph sheet. It passes the test because it is a function. A circle, and the circle will be in the form x squared plus y squared in 1. That is a circle like this. Fails the test because it is not a function. We will see much of it at the next section, where a circle will be drawn, then we apply the vertical line text on it. A linear graph like y equal to 2x passes the test. It is a function, yes. And a sideways parabola like x equal to y squared, it fails the test because the vertical line will definitely intersect more than one point. Let's move to the next slide, which so you can see some graphs sketched here, and they are vertical line tests to indicate whether they are functions or not a function. And when it comes to this section here, when you plot the graph of x equal to 1, which I think it is missing here, sorry for that, it will be a line passing through x at the point where s is 2, and it will be parallel to the y-axis. That means we are having only one input having a lot of output, and that fails to be a function. Okay, so we can move to the next section, which we can look at the graphs here. This one, we can have a parabola in the form that is facing the x-axis rather than the normal y-axis, and here the vertical line text is here, which this one failed to be a function. This one is also a function because it is the vertical line test passes through one particular point and it passes the test. So you can also look at these particular diagrams, and you can relate them to your understanding how you can use the vertical line test to dictate whether it's a function or not being a function. We move on to relation versus functions. So as we said, a function is a relation, but not all relations are function. So at this session, look at relation, this one relation F, relation G, relation H. Now, before you move on to the next section, think of it by the definition of a function. Which of these relation signifies a function and which of them is not a function? With reasons and understanding. I'll move to the next section. Let's understanding the diagram. Understanding the diagram. Relation F valid as a function is valid as a function. Why? Because each element in the domain maps to exactly one element in the codomain. When we were starting the class, we've already have the definition of domain and codomain when we were dealing with relations. So let me have a summary of it for you here. The domain is a set that contains the input, the set that contains the object, and it is a set that is normally represented as the X. And let's go to the codomain. Codomain is also the set that contains all the possible images, the possible outputs. So for the relation F, no element is left unmapped or duplicated. Therefore, it is a function because every element in the domain was having only one element in the codomain. That makes F to be a function. Relation G is not a function. Why? Because element 0 in the domain has no mapping. Functions require every input to be mapped. So it means that we don't have to see any element in the domain without an output in the codomain. Therefore, this is not a function. Then relation H is not a function. Why? Because there is an element B which maps to both F and G, and it is not a function because we define a function that it must map the out input map must map to only one output, not two. And the element B was having both F and G as its output. Therefore, that is not a function. Thank you.